Hi everyone. So this is Xiaofu. So I have both the background from electrical engineering and also mechanical engineering. So currently I'm working on algorithm. I'm working on something like algorithm stuff in a large tech company. So here I would like to continue to actually to do the second tutorial to help you to learn some of the basics of FPAA. So as for this tutorial, so we would like mostly to learn some of the basic information of the FPA simulator. As I mentioned from my last tutorial, basically you do everything in the simulator. After you build the circuit in the simulator, you simulate in the simulator and then download directly to the FPAA board. And other than that, so in the simulator, the CAM is a main block or the main module. So CAM stands for configurable analog modules. This is the module which can do most of the math operations, such as summation, subtraction, and also multiplication. And here, after I introduce some of the CAMs in the simulator, we'll do some quick examples. So here, this is how you say the original FPA, how it looked like, the original simulator setup, how it looked like. And from there, so when you open up simulator, so you just choose the default setting, don't change anything. And you can simply, what I did just now, you can simply drag the each one of the FPA to different locations so that you feel maybe in some of the location you feel wow, and it feels like this is a good location, so you can maybe have even higher working efficiency. So other than that, you in the keyboard, if you press the letter I, so it will zoom in. But right now I have already zoomed in, so we can press another letter O for orange to zoom out. If I press O right now, you see it zoom out, and if you press I, it zoom in again. So that's very simple. So other than that, let's maybe try some very quick examples. Like I mentioned that most of the math operation will be done by using the CAM. So right now we'll insert a new CAM. So here we will do a quick example. We will basically add two constants together. So here we choose sum diff. So let's say we choose it, and this could pop up another window and ask you how you want to deal with this CAM. So basically how you want to set up your CAM. So as you can see that each one of the CAM we have input, we can at most have 4 different inputs. But right now we'll go with a simple one. We will use only 2 inputs. So as each one of the input, you can choose different setup. So you can choose non-inverting and inverting. So that means here you can choose the sign, you want a plus or minus. So other than that, each one of them also has an internal scaling factor. So each one of the scaling factor, you can scale up your input. And if you would like to know more of how the switch capacitor technology work for this CAM, you can press documentation. And from the documentation, they have, I would say, a more precise or accurate explanation how each one of the module work in detail. So as you can see, the input one, so they have non-inverting and inverting input. When they have the non-inverting one, we have a plus sign. And again, as we just showed, it's basically here the scaling factor. And if you really would like to know what was happening for the switch capacitor technology part, you can go here. I'm not an expert for a switch capacitor. So here, this tutorial just served as a technical tutorial, can teach you how you can use FPA to build up some complex circuits. And after knowing that, let's say, okay, we don't change anything. We use both of them as non-inverting one. And then after that, what we will do, we'll add up 2 more CAM. So each one of them, we will use the DC voltage source here. So right now, okay, we will just choose positive 2 volts. And let's see what will happen. So that's let's say that's your first input. And let's say I want another one, you can just say copy. and then paste. You have one more. Right now, I don't want N1 and N2, and I don't know what N1 and N2 stands for. Let's say I said N1, let's say it's our input 1. So basically, you double click, you can change the symbol name. Right now, this one N2, I change it to input 2. So from here, we have N1 and N2. So I will add one more cam to make sure our output is correct. So we'll use sample and hold. In this tutorial, I wouldn't explain that much detail for why I need to use a sample and hold. In the next tutorial, I will explain more details. And after that, okay, right now you pretty much have everything. You have the input, you also have the output. So input is basically just simply input 1 plus input 2. And let's say you need, I would say, a oscilloscope to observe what's happening for the output. So you can go to simply go to simulate, create oscilloscope probe. Let's say I put it one here and put another one. So here is another quick way. You see this little oscilloscope symbol. Let's just simply click it, and we have one more probe. Let's say we put it at the output, and then you can set up the simulation. Set up simulation from here, from simulate, and I already set it up. So we choose it 15 milliseconds. You can choose any other duration of time as you wish. But here in the simulator, FPAA has its own limitation in the simulator. So if you would like to simulate your circuit, you wouldn't be able, you are not able to change the time step. It's fixed. And generally, I will use display oscilloscope like this sighting, make post simulation probing of all nodes possible. So you can also choose another one, display data only at the nodes. Then you will have to put all the probe at different locations which you are interested in. But if you choose another sighting, so basically whenever you move your probe, you can visualize different outputs at different locations. I will click OK. And then let's say there is also a quick way to simulate. You see here, just next to the probe, you have begin simulation shortcut symbol. Let's click simulation. Let's just click it, and it started. So from here, you see iteration is done. Just the left bottom corner. So right now, let's say what's happening for our input and output. Let's say our input 1, what did we set up for input 1? It's just plus 2 volts. And we didn't do anything, we didn't change here the scaling factor, and it should be plus since we chose non-inverting. And let's say, okay, we use a cursor, so you can choose a cursor here. So by using the cursor, let's say our probe is in pink color for input 1, you see it is 2 volts all the time, right? And let's say what was happening for the output. Output from the green probe, it said that it's 3 volts. You might be thinking why it is 3 volts, right? We should have 4 volts as 2 plus 2 equals to 4. That's because of the limitation of FPAA. So FPAA can only work, I would say like the working range of FPAA is between -3 to +3 volts. So let's say we change to a different value. So instead of using 2 for another one, we can use, let's say we choose, we cannot change the value directly here. We can change it from here. Let's say we use inverting input for second input. And instead of using 1, let's say I use 0.5. So we will have 2 minus 1. So eventually we should get 1 volt from the output. Let's see what will happen right now from the output. We can just click the simulation again and to see what will happen. Just a quick start. And let's say, okay, from the cursor, okay, we already turned on the cursor. You can click it and to turn it off. So you see that from the output, we have 1 volt. As we just expect, it should be 2 minus 1, right? So input is if you don't trust me, you can change the pink one to a second input. Let's say what is second input. It's going to take some time to switch it. Oh, all right. So my bad. So since it should be 2 volts again, since it changed in the module, so that'll be difficult to visualize inside of the module. But the output does follow what we expect. So then right now you might be thinking, okay, I don't really like just to use simple DC voltage. Let's see what will happen if we have a different input. Let's say I delete this input and I insert a new cam. So instead of using a DC voltage, we'll use a sinusoid or a sine wave here. And here, let's say we have a sine wave oscillator here, double click, and we have a sine wave oscillator. As I mentioned, like FPA is actually having its limiting working range just between -3 to 3 volt. So we'll use maybe a much smaller value. Let's say we use 1 volt. And okay, so it just error out, it just doesn't like us to choose this frequency range. Okay, it give us I would say the range. When you change the amplitude, the range will also change at the same time, you see. So let's say we'll just follow what they suggest. We'll use 5 kilohertz and click OK. And let's say, okay, that's another input. So you can change input to input 2 as you want. Just double click and you can change it. So let's see what will happen right now. Oh, I accidentally delete one of the probe. Let's just add it back. Let's add one more probe here. Maybe I'll give it for the sine wave. All right, let's simulate again, see what will happen. Okay, right now, let's see what will happen. You see this is the original one, is oscillating. You see the amplitude is 1 plus 1 and 1. And what we choose here, the amplitude should also be 1 volt, right? That follow what we expect. And here, since we use we actually use a inverting and half of it. So that means this one right now will after we half it, so the peak amplitude, if you look at the output, it should be, let's say this is from the green one, this 1.5, 2.5. So peak to peak is 1 volt, so the amplitude is half volt, right? And as we are also shifted by a DC bias, so it is supposed to oscillating around 2 volts, right? As you can see that here is close to 2 volts if you read it from the green color. This readout. So, and as we also use a non-inverting scaling factor, so as you can see that they have a 180 degree or pi phase difference. So yeah, this is pretty much what we have for this tutorial. So in the next tutorial, I'm going to put more details for FPA simulator, and we'll actually also look at some other quick examples, so that you will be able to do some prototyping in the future for your own project. Thanks. And if you really like my tutorial, or you can subscribe to my channel, and you can also leave comments and let me know what you are interested in, or if you are having any other question, I can include it in the next tutorial. Thank you.